Hey guys, I want to edit video number 2 from 4.2. I just want to show you how you can manipulate this problem a little bit more to make it easier to put in your calculator before you identify, and also some critical value points. So I have this derivative here that we found in video 2 of 4.1. So now in order to check for concavity, I need to take the second derivative. So the second derivative using the quotient rule, low, d high, minus high, d low, square the bottom. So in order to simplify this sum, I see that in my numerator, both this term and this term have a common factor of x squared minus 8. So I factored that out of both terms in my numerator. And that leaves x squared minus 8 multiplied by this term minus 4x multiplied by this term. So that's nice because now I can cancel this one with the one in my denominator. And you want to get in the habit of doing that when you have these rational derivatives. It helps to simplify my numerator down just a little bit to here. And now this is my denominator. So first, from my denominator, I know my critical values are at x equals plus or minus square root 8. That's when the denominator equals 0. Now, my numerator, I can use my calculator here to check its critical values. So here in my calculator, I have just my numerator plugged in to graph, because that's the only one now that really matters for finding my 0 or my critical value. So now I can trace it to see when that's equal to 0. So I'm going to click menu, 5, trace, enter, trace graph, and as I trace to the right, I see it's positive y values, they get smaller. Oh, and I have a 0 here. I'm going to press enter so I can save it. So that 0 is at 0, 0, and then it goes positive. So I see my other critical value is at x equals 0. So now I can do a sign check here for my second derivative. My values being 0, square root 8, and negative square root 8. So between 0 and square root 8, I could check 1 for some instance. Now, we have to keep in mind for this rational expression the sign of both my numerator and my denominator, because this denominator might be negative, so we have to keep that in mind. So let's say I plug in 1 here. Well, if I plug in 1 in my denominator, 1 squared minus 8 is a negative, and a negative cubed is a negative. So I know that for this interval, I know my denominator is negative. And now my numerator, if I think about my numerator, to the right of 0, everything is positive. So that's positive. So a positive divided by a negative is a negative, so this is concave down. So same thing with negative 1. Let's check that. Well, first, if I plug negative 1 into my denominator, I'm going to have 1 minus 8, which is a negative cubed, which is a negative. So I know for that interval, my denominator is negative. Now for my for my numerator, I look at my calculator, everything to the left of 0 is positive as well. So I'm going to have a positive on my numerator there. A positive divided by a negative is a negative, so this is concave down. So notice, I know this because when I trace my graph, it's positive until it hits 0, and then it goes back up positive again. Okay, so it's positive everywhere else except for 0. So now here, greater than square root 8, I can plug in any number. Let's say 4 or 5. It doesn't really matter. 5 squared minus 8 will be a positive, and my numerator will be a positive. So this is concave up. And then here, plugging in -5, -5 squared minus 8 is a positive, cubed, which is a positive in my denominator, and my numerator is positive, so it's concave up. So now let's write those intervals of concavity. So concave up, we see it's concave up from -infinity to -√8, union √8 to infinity, and it's concave down throughout this entire interval from -√8 until √8. So if you have a concave down and next to a concave down, that whole interval is just concave down. So please note those changes, and we also need to check for points of inflection. Points of inflection happen where it changes from concave up to concave down. So I, just for space saver, I'm going to write here in pencil, this is my first point of inflection, and here is my other point of inflection. And that would be this x value and also that x value plugged into this function. So we will practice points of inflections and concavity in class together.